Hello class, today we're going to look over chapter 20. We're going to talk about lists and iterators. And unlike the previous unit, previously we talked about the Java collection framework, and we talked about how the collection framework contained linked list. Today what we're going to talk about is how we make our own linked list as if Java did not include it for us. We're going to build our own linked list, and we're going to talk about a list node object as a way of then building up our own linked list. We're going to talk about different kinds of linked list. We have singly linked list, we have singly linked list with tails, we have doubly linked list, and we have circular doubly linked list as well. And we're also going to talk about creating our own do-it-yourself iterator as well as your own do-it-yourself linked list. And we're going over this this kind of do-it-yourself kind of style linked list as a way of understanding in a deeper level what linked lists are all about. So in a singly linked list, we see a bunch of nodes here, and every single node has two pieces of information in it. Every node has a value, and every node has a reference to the next node. And so the value itself could be any sort of item, any sort of object you want. It could be, a person, it could be an integer, it could be a string. The very last node of our linked list references nothing and is null. Now you notice the interesting thing about a singly linked list is that the only way to get to, say, this value right here is to start at the head and then iterate through each one, because the only way to get to v2 is to get to this node v1. The only way to get to this node v1 is to start off at this node here v0. And you can also notice that once I'm at this node, I can't go backwards. I could only ever go forwards in a singly linked list. Notice we also have a head reference, which is a reference to the very first node in the list. Okay, so let's look at how we make a singly linked list node. And remember, there are two pieces of information, a value and the next. Now here in Java, we're going to typically use these what are called generics. And so this is a generic type parameter that says, oh, I want to create a list node that contains a string, contains whatever you want. So we use, Java uses this less than sign E, greater than sign here as a way of creating these what's called generics. So we create two fields, a value of type E, and a next field, which is a list node of this same type. It's our reference to the next list node. So we have a constructor here, a very simple constructor, which takes an initial value and initializes the value, and it sets next to null. And we have another type of a constructor which takes in both the value as well as the next link and initializes both of them at the same time. We have our getters, which allow us to get the value or get the next node. We have our setters, which allow us to set either the value or the next reference as well. That's basically it. This is our list node. And we connect a lot of them together to create our linked list. So now we're going to look at some operations we can do with a linked list. So very commonly what we want to do is we want to traverse. We want to start at some point, say, actually this doesn't have to be the head, we could start at any point in the list. This is our input into our method. We set up this for loop to start at the head, and as long as that node is not null, go and get the value and do whatever you want with it. In this case, we'll print it out. And then advance the node to the next node, and then repeat and keep on iterating until you get to the very end. Now, it's an important thing to note that we always want to check to see whether or not this node is null before we call a method upon it. Otherwise, we're going to get a null pointer exception error. So this is a very, very common thing you'll see. as long as the node is not null, go ahead and do something with it. That's our stopping condition. And again, this just advances us to get the next node. Okay, let's look at appending. We're going to first look at appending, and when I say appending, we're going to append it at the very beginning of our linked list. So we want to put a new node right in front here. So here's the new node that we want. We want to have a new node with this value given this head to the linked list. So what we're going to do is we're going to create a new node. This new node will have the value initialized, and we're going to assign the reference here to point to the head. And then what we're going to do is return this node back to the caller, and then the caller will then reassign head to then point to this new node. So you can see here that appending is very fast. When we add a value to the very front of a linked list, it's an O1 type of operation. It happens instantly. Unlike an array list, where if I wanted to put something at the very beginning at index position 0, I have to shift all the other values down before I can put that new value here. But in a linked list, the append or the add to position 0 is very, very fast. Okay, let's look at removing. Removing, in this case, we're going to remove the last node here. Now, in this case, we're going to first write the code assuming there are at least 2 nodes in the list. So when we want to remove this node here, what we actually want to do is turn this node here to null. And a very common kind of thing to do, or maybe initial way of thinking is, oh, I need to iterate all the way to the very end. And once I get to the very end where I see this is null, then I want to make this previous node's next reference null. But if I'm already here, then I can't go backwards. So actually my plan, the idea is to iterate through and stop right at this point at the second to the last node. So I'm going to create an initial node reference to the head, and then I'm going to iterate one by one. As long as the next is not null, I will advance it by 1. The next is not null, so I will advance it by 1. The next is not null, so I will advance it. And at this point, I stop, because here the node get next is null. I'm all done. Again, I'm stopping at the second to the last node in the list. And once I'm here, I'm going to turn this node to null. You can see right here. And then that basically kind of throws away that other last node. Now, the challenge with any sort of do-it-yourself linked list, there are 2 major challenges. Challenge number 1 is all the corner cases. Now, it's very easy to deal with linked list in the middle of the linked list. The corner cases are always the problem. The corner cases are whatever is at the beginning of the list or maybe at the end of the list. And in each of those 2 cases, you have to be very careful. And my tip is to draw diagrams for each of those different situations. Always, always, always think about the beginning and the end. Maybe the beginning is easy, but maybe the end is hard. Or maybe vice versa. Or maybe you have to deal with both the beginning and the end in a special way. Basically, just stop and think about those issues. The middle is always easy to do. The other thing you have to be very careful about is the sequencing of your linking or unlinking whenever you insert or remove nodes. What you don't want to do is you don't want to lose your linked list by doing it in the wrong order, and I'll illustrate that in a second. Okay, so corner case examples. Let's go back to the removing of the last node. Now, we talked about the scenario where there are 2 or more items in the list, and that's the easy case because we basically just traverse along there until we get to the second to the last node, and when we get there, we just turn that into null. But we have two different corner case conditions. Corner case number one is there's nothing in the list at all. It's empty. In this case, there's nothing to do actually, and you just return right away. The other case is that there is one item in the list, and in this case, what we do is we just set the head to null and then return that value. Okay, so let's actually rewrite the remove last method kind of in a more complete way now. So in this case, I'm going to modify this remove last. I'm going to actually modify it with a return value so it returns the new head. Because if we look back at this previous situation here, it's possible that our head changes. In the case of two or more items, the head did not change. In the case of an empty list, the head did not change, but in the case of one item in the list, the head must change to null. And so that's what we're going to demonstrate here. We're going to actually return the new head. So starting off with the empty list case, if our head is null, just return null. If there's only one node, meaning head.getNext is null, again, return null. Then we have the 2+ node case, which is what we had earlier, where we iterate where the second to the last node is found. Once we find the second to the last node, we set that to null, and then we return the head, which is basically what was supplied to us. So this is the more complete case where we thought about all the corner case conditions, and again, in this particular case, it's the beginning that we have to be extra careful about. Okay, the other difficult thing to deal with in do-it-yourself linked list creation is sequencing, the sequencing of your linkages. So let's take an example where we are inserting a node into a linked list. So suppose I have this linked list here, and I want to insert this node here in between these two, right after v2. So suppose I have a variable n that points to this node here. And ideally, what I want it to look like is I want it to look like this when I'm done inserting it. Now, how do I do this? What's the order? I either make the red link first, that would be n.setNext new n, and then I follow it by making the blue link, and this is the instruction to create that, new n set next n.getNext, which is referencing v3 here. Or I do it the other way around. I make the blue link first and then the red. So which one do I do? Let's look at it. So let's go back. And let's examine the case where I do this one first. So I'm going to set this node to point to this node, which then makes this link disappear. So then if I try to set this node here to reference this node, I can't because this linkage is gone and I have no way of knowing what this is anymore. So that's not a good sequence. Instead, what I should do is I should first create this linkage, setting the next of this to n.getNext node here, and then I create the red link here. So the sequence, proper sequence, is 1 followed by 2. So sequencing, always think about this, draw a diagram, do what I just did right here to make sure that you don't lose the entire list because you made the link too early. So if I made the link to, this red link first, I've lost this list right here. It just kind of disappears and I can't get it back. Okay, so let's now look at do-it-yourself iterators. So now that we've made a singly linked list, let's also add to it, let's implement the iterable interface of Java. Now, to do that, we need to implement the iterator method here. And the iterator method here just simply returns an Iterator. Okay, so I highlighted these two words here because this is an iterable and this is an iterator. So what the iterable interface does is it implements this method here, which returns an iterator. Okay, very kind of confusing. So anyways, what we are going to look at next is how do I make this singly linked list iterator? What the iterator does is it basically keeps track of where we are in the linked list and returns the next value. Oh, so this is the key thing of an iterator. It's a field that holds the information of where we currently are in the linked list. So our constructor has a starting point, and you can give it any particular node in the linked list as your starting point. Very typically, you'll give it the head, but generically it can be anywhere. So this is our starting point, and we set up this next node field to be that starting point. And then we have our methods that are implementing the iterator interface. HasNext tells us, is this a node? And so if it's not null, we return true. And then next itself, what next does is that it gets the value and returns the value. So next doesn't return the entire node, but basically it returns the next value of the item in our linked list. And then it advances the kind of pointer to point to the next node after that. So it remembers where we were, and so next will always retrieve the next value, next value, next value. And we have this little safety here just in case, somebody called next when they shouldn't have. So those are do-it-yourself iterators. Now, we're going to end this lesson by talking about other kinds of linked list. A singly linked list has limitations because you can imagine to get to the very end, I have to iterate from the beginning all the way to the end. So there's a variation called a singly linked list with a tail, such that I have a pointer, another reference that points to the very end. So in this case, I could append to the very beginning, or I could add a node quite easily to the very end. And so in this case, adding to the end is also an O1 activity. Now, there's limitations to this because I still can't go backwards. So if I wanted to get to this node here, I'd have to start at the very beginning and advance all the way forward to get to the second to the last node. But a singly linked list with a tail is quite good for queues, which allows us to add to the beginning, add to the end, take away from the beginning very easily. We'll get to that later, though. Okay, next variation. I talked about how singly linked lists only really are convenient in going one direction, traversing forward. So to traverse backwards, what we can do is, for every single node, we can add another field. So we add a previous field as well as the next field. So the previous now will point to the previous node, which will allow us to go backwards. So in this case, the very last node will be set to null, and the very first node's previous will also be set to null. And this allows us to go in either order, which actually makes things quite convenient. The downside of it, of course, is that every single list node now has an extra kind of piece of data storage. I have to have a previous reference as well as a next. So there's a cost involved in a doubly linked list. Okay, another variation we have on top of this is a circular list. So in a circular list, the very last node's next points to the very first node, and the very first node's previous points to the last node. And this makes it kind of convenient for just kind of going in a circle And this is actually very similar to how Java does it. But Java takes one more additional variation upon this. Instead, it's a doubly linked list with a header node. So a header node is exactly the same as a list node, but in this case, the header doesn't contain any kind of useful information inside of its value field here, but instead it's just pointing to the first and to the last nodes. So this is the way Java actually implements a linked list. Okay, so that's it, class. This is the lesson on do-it-yourself linked list. You can review these questions here, think about them, and the answers are on the next page in your notes. Okay, have a good day, everybody.